Hello all and welcome back. So in this video, let us move forward and now let's try to understand some terminologies in our tree. So let's get started. Now the very first one, let us discuss that directly. We have a tree in front of us, okay, which you can see on the right side. The very first one is the node. So node is just your each item of our tree, right? So each item of my tree. Now we are going to understand how exactly are we going to define it, but for the time being, you can say, as you can see in front of you as well, this particular, right? So this A is a node, right? So it's a node. B, C, D, all of these circles which you see, they are actually node in my tree. The second terminology can be the edge. So the connection between two nodes, as we can see in front of us. So connection between two nodes, right? So for example, if you see here, this is an edge, this is an edge. Rather, each and every way the nodes are connected, they are actually an edge. Okay, great. So let us see the next one, everyone. Next one is the root. So root, we can say that is the topmost node. So now we know about node, right? Topmost node. So this particular node is a root. Okay, so we have seen this in the last few videos as well. Like this particular, it's a root. Again, very important. Let me draw it in green. So just like we used to get head in our linked list, root is the thing which we are going to get in our tree. Okay, because that is from where everything starts. Then the next one is our leaf. So leaf, just like in a tree, a leaf doesn't have anything. It's like towards the end. Here also leaf is something which is no children. So node with no children, right? So pretty easy to spot all the leaves here. This is one leaf. Then this is other leaf. Drawing it in green so that we remember the same. And this is one more leaf. Right, everyone? So let me write that down as well so that we can see the same. These are your leaf. All of these are our leaves, right? Because they don't have any children. They don't have any children. Unlike other notes which you are seeing, these are my leaf. Again, very important. We get lots of questions and use case of this. In a file structure, a leaf can actually be a file because inside a file nothing is there. Whereas a folder can be a node which has children. Okay. So a folder can have multiple childrens and files, but a file, that's the end, right? There you cannot have anything. Great. So the next one again is pretty easy to understand. Parent. Okay. So I think this we can easily understand. B is the parent of E and F, right? So again, this terminology is coming from your this thing from your overall family tree. That B, it is parent of C and F. C doesn't have any children, so it is not parent of anybody. D is a parent of G. G is the parent of I. And of course, A is the parent of A, B, C. Okay, so pretty easy to understand. On that note, similarly, we have the sixth one, which is child. So on the very same note, E is the child of my B. Right, I hope this is overall a lot easy to understand. Maybe I can just mention that this is the child and this is the parent, right? Great. So these are the basics one. Now, few of more is like we can understand about ancestors. Again, this is coming from the family tree use case. So everything which is above, like let's say for E, okay, B and A are is ancestors, right? These are ancestors overall, right, everyone? So one thing to note here, everyone, when we talk about ancestor, like where the major mistake is done, for let's say E, okay, so for E, its ancestor are B and A, okay. So this C and D are not its ancestor, okay. So I will write this down as well. E ancestors are A and B. Okay. Similarly, for H, the ancestors are F, B, and A. So for my E, C is not an ancestor. Okay, so we just see the E basically from where we are coming. Okay, we are not being connected with C. Okay, you can in family terms you can see that it's an uncle. Okay, something like that. But again, they are not the ancestors. Okay, in terms of tree terminology, we are not related, right? Just like ancestors, we have the next one which is descendants. Descendants, right? Again, just opposite. So, for example, for my B, the descendants are E, F, and H. Okay. For A, all of them are descendants. For D, descendants are for D we have G and I. For D we have G and I. Now again, A is the ancestor of each and every node because of course A is from where it started, right? So that is where the tree started. So each and every node is an ancestor of my A. So that thing you have to understand. And yeah, these are I think the major one which we have to use uh, for the defining of my tree, or if let's say any question is asked. Along with that, just few more things. So this overall, okay, let me find a color which is light a little bit. So this, as we have already discussed, this can be called a subtree, right? So this can be called something of a, I think this works. So yeah, this is a subtree, something which we have already discussed, right? If you see this, this is a separate overall tree starting, right? I could have taken the H as well, but should be fine. So I can say and write here subtree, right? Marked in violet. Great, everyone. So the last one can actually be something we call level. Now, there are few more terminologies, but I will be introducing them as and when we will understand how to find them. Okay, so don't want to confuse you a lot. Level actually something is, we say that our root is at level 0. So for level, let me try to draw it as well. And I know this will be a lot information heavy diagram, but pretty sure you must have understand it. So level wise, I say that, okay, this is level 0. Okay. Then this is level 1. Again, you can very well say that many places you might find that the root is at level 1. Okay. This BCD are at level 1, level 2. So that should not be a problem. Overall, we should have an idea that, okay, this is how level is defined. So this can be my level 2, right? This can be the level 3. So this is the level, how it is defined. Okay. So yeah, I know this is a little bit overall information heavy slides, but I wanted to make sure that you have a proper resource to refer if you are ever confused between these terminologies. Now, other I'm going to define as and when we see, as and when we are trying to find the same. Okay, just one last one which I can also throw is that, and one more thing, so level and depth are same. Okay. One last one which I can throw is path. So path is actually defined as something sequence of nodes and edges which is connecting a node to another. So let me write it down. Sequence of nodes and edges connecting one node to another. One node to another. Just that always make sure that we can only move up downwards. Okay, so I will explain what I mean by that. We can only move downwards. What I mean by that is, so first let us understand about the path. Okay, for my A, if I have to go to F, this is the path I will take, right? This is the path which I will take. For B to go to H, this is the path. But for H to go to E, I am saying that I cannot move in this direction because this is not how it is going, right? So the way path is actually defined, okay, the way path is defined is that we can only move in the direction our tree is defined. Okay, so it's not bi-directional. Of course, it is a single direction where we can go. Then there is also something which you will heard as siblings. So these are siblings, right? Which is having a common parent. Pretty sure that is easy to understand, right? For B, E and F are siblings. Okay, whenever you have a common parent, so just like you, your brother, sister, because you are having a common parent, you are known as siblings. Then these will become cousins. Now I'm not writing that down. I think they are a lot intuitive based on our family structure, family understanding, and that is where again the tree has put up or taken these terminologies. Okay, so these are the siblings, these are the cousins, right? And yeah, I think these are good terminologies to start with so that you always have an idea. As and when other will be required, though I think we have covered majorly what all might be required. We will be discussing them going forward. But if you are able to understand this, just what I will suggest now is try to draw this once again. Okay, try to draw this whole diagram at your end and write these terminologies. Okay, so without after seeing the video, try to actually mention that okay, who is related to what. For example, who are all the ancestors of a particular node? What are different subtrees? What is the level and depth? Once you do that, I think it will be pretty straightforward. I've made sure that for an interview or any important call or work, you have a good slide to refer to for all the terminologies in a tree. Great, everyone. So let's move forward now. In the last video, we have now understood exactly about the tree. In this video, we understood about some terminologies. So going forward in the next videos, we are going to implement our tree via code. Okay. So great, everyone. Please make sure that you revise this properly. It's going to be a lot useful. Thank you.